Hello everyone, welcome to lecture 6 of CIN 635, and in this week we shall be looking at basics of cellular concept. In the past decade, cellular communications have experienced an explosive growth due to recent technological advances in cellular networks and cellular telephone manufacturing. Early schemes for radio telephone schemes used a single central transmitter to cover a wide area. These radio telephone systems suffered for the limited number of channels that were available. The figure shows a basic cellular system which consists of mobile stations, base stations, and mobile switching center, MSC. The mobile switching center is sometimes called a mobile telephone switching office or abbreviated as MTSO, since it is responsible for connecting all mobiles to the PSTN in a cellular system. Each mobile communicates via radio with one of the base stations and may be handed off to any number of base stations throughout the duration of a call. The mobile station contains a transceiver, an antenna, and control circuitry, and may be mounted in a vehicle or used as a portable handheld unit. The base stations consist of several transmitters and receivers which simultaneously handle full duplex communications and generally have towers which support several transmitting and receiving antennas. The base station serves as a bridge between all mobile users in the cell and connects the simultaneous mobile calls via telephone lines or microwave links to the mobile switching center. The mobile switching center coordinates the activities of all of the base stations and connects the entire cellular system to the PSTN. A typical mobile switching center handles 100,000 cellular subscribers and 5,000 simultaneous conversations at a time and accommodates all billing and maintenance functions as well. In large cities, several MSC are used by a single carrier. The need for an efficient spectrum system. To illustrate the need for efficient spectrum usage for a radio communications system, take the example where each user is allocated a channel. Each channel needs to have a bandwidth of around 25 kilohertz to enable sufficient audio quality to be delivered, as well as enabling there to be a guard band between adjacent signals to ensure there are no undue levels of interference. Using this concept, it is only possible to accommodate 40 users in a frequency band 1 megahertz wide. Even if 100 megahertz wide were allocated to the system, this would only enable 4,000 users to have access to the system. Today, cellular systems have millions of subscribers, and therefore a far more efficient method of using the available spectrum is needed. In order to accommodate more subscribers, the size of cells must be reduced. To make more efficient use of the limited frequency spectrum allocation, this will add to the challenge of some fundamental issues in cellular networks. In a cellular network, a service coverage area is divided into smaller hexagonal areas referred to as cells. Now, cell systems. Each cell is served by a base station. The base station is fixed. It is able to communicate with mobile stations such as cellular telephones using its radio transceiver. The base station is connected to the mobile switching center which is in turn connected to the PSTN or public switch telephone networks. Cellular radio is a technique that was developed to increase the capacity available for mobile radio telephone service. It is an underlying technology for mobile phones, personal communication systems, wireless networking, etc. This technology is developed for a mobile radio telephone to replace high power transmitter or receiver systems. Cellular network uses lower power, shorter range, and more transmitters for data transmission. A cellular network divides any given area into cells where a mobile unit in each cell communicates with a base station. A hexagon cell shape is highly recommended for its easy coverage and calculations. It offers the following advantages: provides equidistant antennas, distance from center to vertex equals length of size. Cell cluster. Cell cluster is a group of cells in which cells are arranged such that no frequency channels are reused. The size of cell cluster is defined by the number of cells in the cluster. For example, the figure illustrated in this slide shows 3 clusters with size of 7. Types of cell in mobile communication. Even though the number of cells in a cluster in a cellular system can help govern the number of users that can be accommodated, by making all the cells smaller, it is possible to increase the overall capacity of the cellular system. Accordingly, in areas where there are more users, small low-power base stations are installed. There are 4 types of cells in mobile communication, and these include femtocell, picocell, microcell, and macrocell. Let's have a look at these in way much more broad. Femtocells. Femtocells are small, low-powered cellular base stations that are used predominantly within home and small businesses. A femtocell is able to connect to a service provider network via broadband to deliver connectivity to mobile devices. Picocell are generally used for covering very small areas, such as particular area of buildings or possibly tunnels where coverage from a larger cell in the cellular system is not possible. Obviously, for the small cells, the power levels used by the base stations are much lower and the antennas are not positioned to cover wide areas. In this way, the coverage is minimized and the interference to adjacent cells is reduced. Microcells. Microcells are those that are normally found in densely populated areas, which may have a diameter of around 1 kilometer. Macrocells are large cells that are usually used for remote or sparsely populated areas. These may be 10 kilometers or possibly more in diameter. Noise and its effect in mobile communication. In any communication system, during the transmission of a signal or while receiving the signal, some unwanted signal gets introduced into the communication, making it unpleasant for the receiver, questioning the quality of the communication. Such disturbance is often called as noise. Causes for noise. There are various causes for noise that can interfere with wireless networks. Noise can have natural, example, atmospheric interferences, or man-made causes, example, electrical transformers. Generally, however, noise can be any noise that comes from a source outside of the wireless network classified as external or either internal. External noise is any noise that comes from a source outside of the wireless network. Refer to any noise that is generated within the wireless network. For instance, suppose you are trying to reach someone via radio, but the communication is distorted because another radio in the vicinity is generating noise that interferes with the signal. Other causes of external noise can include severe weather and electrical appliances. Internal noise, on the other hand, refers to any noise that is generated within the wireless network. This would be akin to you shouting while your friend is trying to talk to you. Types of noise. The classification of noise is done depending on the type of source, the effect it shows, and the relation it has with the receiver. There are 4 types of noise, and these are thermal noise, intermodulation noise, crosstalk noise, and impulse noise. First type of noise that we shall be looking at is thermal. Thermal noise occurs in all transmission media and communication equipment, including passive devices. It arises from random electron motion and is characterized by a uniform distribution of energy over the frequency spectrum with a Gaussian distribution of levels. Every equipment, element, and the transmission medium itself contribute thermal noise for a communication system if the temperature of that thermal or medium is above absolute zero. Whenever molecules heat above absolute zero, thermal noise will be present. The more heat generated or applied, the greater the level of thermal noise. The next type of noise that we shall be looking at is intermodulation noise. Intermodulation noise is a result of the presence of intermodulation products. If 2 signals of frequencies F1 and F2 are passed through a non-linear device or medium, the result will contain intermodulation products that are spurious frequency energy components. These components may be inside or outside the frequency band of interest for a particular device. Intermodulation products result when intermodulation noise products result when 2 or more signals beat together or mix. The next type of noise that we shall be looking at is crosstalk noise. Crosstalk refers to unwanted coupling between signal paths. There are 3 essential causes of crosstalk. First one, electrical coupling between transmission media, such as between wire pairs on a voice frequency cable. Second one, electrical coupling between transmission media, that is defective filters or poor filter design. And the last one is electrical coupling between transmission media again. The next type of noise is impulse noise. Impulse noise is a discontinuous series of irregular pulses or noise spikes of short duration, broadly spectral density, or of relatively high amplitude. In the language of trade, these spikes are often called hits. Impulse noise degrades telephony only marginally, if at all. However, it may be seriously corrupt error performance of a data circuit. And this finishes our lecture 7 for this particular week. Thank you for listening, everyone.